Here's the same code I've been using throughout this module, and I've built it a number of times, but let's build it one more time to be certain that it still builds. Build succeeded. Yay! Must be wonderful code, right? Well, let's actually take a look at the error list. It turns out there are two warnings on this code. One says you redefined that macro for limit, and the other says, well, you're using compute type here in the enum name, and that's a non-standard extension. These are both warnings. One of them, the macro redefinition, is, I think, actually pretty serious. It's exposing a huge error of thought, and it's just a warning. Let's make another error of thought. Let's go up to this one. And you know how sometimes when people want to test that something's equal, they accidentally, because they come from another language, type just a single equal sign that has the effect of setting I to 3. And then that assignment returns the value 3, which being non-zero will come out as true. So if I comment this out so that I would still be minus 99 from having called, you would expect that this, if I was genuinely properly testing, is equal to 3, it'd be false. But if you've made this error of thought and just said equal sign, this will change it numerically to 3. You might hope that this would get you a warning. I'm going to build it. Build succeeded. Go to the error list, and it does not warn me. The reason is it's an appropriate and sensible C++ idiom to do assignments inside ifs. One of the very common things back when we would use pointers more than we do today is something like if this pointer p, which is equal to something that returns a pointer, blah, blah, blah. Now, this isn't asking, does p equal the return from that? It says, call something that returns a pointer, put the value into p, and if it's not null, carry on and do something using the pointer. As a result, warning you every single time you had an equals sign and an assignment in an if would warn on all of that code. So by default, it doesn't. However, I can ask to be warned at a higher level. So if I go here to my project, properties, and I expand the C++ section and choose general here, you see that we have a warning level is right now level 3. And I can just drop this down and choose level 4. Say OK. And build again. My build still succeeded, but now I got 5 warnings. This one here, unreferenced formal parameter, is pointing out that down in holder, when I take that resource pointer called R, I ignore it. That's probably an error of thought. Why does my function take a parameter that it never does anything with? Hard to argue with that. It's not good code. We still have the macro redefinition and using the enum name, again, a warning about the unreferenced formal parameter, and here, assignment within conditional expression, which is this line right here. So putting your warnings up to 4 exposes a lot more mistakes of thinking that maybe when they're drawn to your attention, you're like, yeah, I could be better here. Well, if 4 is good, maybe even more is better. Let's go on in here and try all. Wow, 89 warnings. And most of them from various headers I've never even heard of. Something about exception specifications and function not inlined, and I can't choose whether or not things are inlined. I generally find that W all is not a happy place for me. I like being at 4. I don't like being at all. So let's go back to 4, and I'll show you this other setting, treat warnings as errors. If I change this to yes, and build. Remember we had 5 warnings at 4. The first warning is labeled warning treated as error, no object file generated. And then I get my other warnings coming out as warnings, but I can go to each individual one and try to fix them up. So this unreferenced formal parameter, for example, all I need to do is just take the formal parameter out. This is still the function that takes a resource pointer. I just don't give it a name, and that error will go away. So I can build, and those are gone now. We have the limit macro redefinition and the non-standard extension used. In fact, I'd already taken away some of the unreferenced formal parameters just to make the error list a little smaller for us here in the main. The same thing works. You still take the types, but if you don't give them names, then the fact that you don't use them isn't considered to be a warning. Now, what if I wanted to keep its name? Let's put it back here. But I also wanted to say that I understand I'm not using it and that that's just deliberate that I'm not using it right now. Let's get the error again. The warning has this code on it, C4100, R, unreferenced formal parameter. I can turn off error 4100. And ideally, of course, turn it back on again right afterwards. Now, if I blindly turn it off and then turn it on, if for some reason it was off throughout the program, it'll now be on again after this line of code, which could mess people up. So there's a pattern or an idiom that we follow when we're turning off warnings, which is that we first save the current warning suppression state, whatever that might be. We then change it so as to turn off one particular warning while compiling this single line of code, and then we restore the warning level state to what it was before we compiled this line of code. And the way that's done is like this. This is a pragma. It's a direction to the compiler. This says, I want you to take all of your state about warning levels and push it onto your stack. Save it, in other words. Now, there's no semicolon at the end of this line because this is a directive to the compiler, just like the include and the define and those sorts of things. Having saved the state of the warning situation, I can then issue another pragma, again about warnings, in which I say disable 4100. That being the number from right here in the warning. Don't worry about the C, that stands for compiler. Then I can process my line, which has an unreferenced formal parameter, and then pop that saved warning state back off the stack so that we're back to normal. This says, I know I have an unreferenced parameter in here, and I don't want you to tell me about it. Sure, deleting the R did that also, but this is super expressive, and it's almost like a to-do comment to you as the developer. Hey, remember that you take a resource pointer, but you're not actually using it right now, and maybe someday, obviously, you would like to. So let's build it now. Again, my build failed because I have warnings set to errors. And if you look at these two, redefining the macro from 3 to 4 in the middle of my code is very hard to defend. It's really not good behavior. And this non-standard extension where I'm using the enum name as part of the talking to the enum value, this is just wrong. It's just something that people do when they come from other languages, and Visual C++ lets you get away with it, but it gives you a warning that you shouldn't be doing it. So let's stop doing that, and let's stop doing that. Speaking of insane. And let's build this. And now we're left with the assignment in the conditional expression, which is totally an error of thought. So we'll fix that. And now when we see build succeeded down here, we know it really, really succeeded. If we bring up the error list, there are no errors, there are no warnings. This code is completely clean. And by setting my project properties to crank my warning level to 4 and treat warnings as errors, long before any runtime problems need to be found, I found a number of things that were wrong with this code. I say it a lot, the compiler is your friend. The compiler is your friend because it finds things sooner. Turning your warning level up so that it catches more things, treating warnings as errors so you have to look. That's asking the compiler, help me more. Find me the places where I wasn't thinking. Some of the brightest minds I know ask for that help from their compiler every day, and you should too.